a whirlwind tour of a huge amount of work and research that is not easily summarized in a 45-minute, 50-minute talk, but we'll do what we can. So thinking about the creation account in Genesis 1, we see God repeatedly creates creatures according to their kinds. You see it when he creates the land plants, and then the sea creatures, and the winged bird, the flying things, according to its kind, and the wild animals according to their kinds, livestock according to their kinds, creatures move along the ground according to their kinds. These are all sort of the categories that God created things in, I guess. We don't really understand the language here. That word kind is in Hebrew mean, and it's used extremely infrequently in the text. And so what exactly it means, we're not sure. It could mean just all varieties of, it could mean something like a type of something. We're not sure. But what we do notice here is that all these living creatures, all these different sorts of creatures, and this is the important part, have their origin within this creation week. So even though we may not know exactly what a mean is supposed to mean and according to its kind is supposed to refer to, we still have this sense that when the creation week is done, and if you could walk through the Garden of Eden, you would have seen fruit trees newly created, you would have seen mammals and birds newly created, you would have seen reptiles newly created. There was not sufficient time here for there to be grand, large-scale evolution, okay? So you start the week with no living things, you end the week with all of the different sorts of living things. That's not favorable to universal common ancestry of all living creatures. And within the broader groups then, we have the critters that are made after their kind. And again, we're not real sure what that is, but creationists have sort of combined this phraseology with a lot of biology to come up with this notion of the created kind. We'll talk about that in a second. But what I want to emphasize here are the differences rather than the similarities. Well, kind of both, really. You have differences in the sense that it's emphasizing things that swim versus things that fly. They are distinct categories. Whereas within the things that fly, there are a bunch of things that fly, right? There's lots of different sorts of birds. And so you have this combination of similarity and difference. Now, modern studies of created kind really go back to this fellow right here. This is Frank Marsh. Frank was an early pioneer in creationist biology. He completed a doctorate in plant physiology in 1940. And by 1941, he had self-published a book that he called Fundamental Biology. And in that book, he proposed two kinds of things here. The first one being that hybridization only happens within created kinds. And he coined this term Brahman. And Brahman comes from the Hebrew bara, which is to create, and mean, which is kind, so Brahman is a created kind. And if you ask Dr. Boyd about it, I'm sure he'll tell you that that's backwards. It's supposed to be mean bara, but Dr. Marsh didn't know that much Hebrew, so we still have Brahmins, and we're still going to call them Brahmins. I'm sorry. All you Hebrew guys watching, I'm sorry. All right, so after its kind is a biological law of reproduction, according to Marsh's claims. He claimed this, and I say this is wrong, he claimed it because he claimed that the Bible teaches that kinds, created kinds, only reproduce after their kind. And that is not actually what the Bible says. The Bible talks about God creating things after their kind. And indeed, after its kind is used 11 times in Genesis 1, 10 of those times it's clearly referring to the creation of the creature. The 11th time is ambiguous. It might be referring to fruit, or it might be referring to trees that bear fruit. Either way you go, the Bible doesn't really explicitly say that after its kind means that you can only reproduce after its kind. But that's what Marsh thought, and that got him going. And that led to this notion that the successful hybridization only happens between members of the same kind, which we now think of as the hybridization criterion. So if you have two different species that can cross and produce a hybrid offspring, then that means that the two parent species belong to the same created kind. Pretty simple. Example, mules. Here is a mule. We all know about mules. Mules are the offspring of horses and donkeys. Cross a horse, which is one species, with a donkey, with another species, you will get a mule, which looks like this. There are other horse hybrids as well. For example, the zonkey, which is a cross between a zebra and a donkey, and of course the zorse, which is a cross between a zebra and a horse. It turns out that among all the different sorts of horses that are in existence today, there's probably 7 species that are recognized. All the hybrids that are possible are known. Every one of them. So Marsh would look at this and say, clearly horses, donkeys, zebras, every kind of zebra, they all belong to a single created kind. And by that, he would understand that if you go back in the past far enough, you would come to a point where there was kind of one horsey thing that diverged into the modern horse species. So that's where Marsh left us. He passed away, oh, goodness, back in the early 90s. So that was a good, well, getting on to 25, 30 years ago. And he left us with this notion of hybridization as the defining characteristic of a created kind. Species that can produce offspring are members of the same created kind. There are, however, limitations, important limitations, to what Marsh was proposing. Hybridization is only applicable in certain cases. So, for example, there's a whole lot of asexual organisms out there. And if you don't cross to make babies, well, you can't really cross the different species, right? So that's a whole swath of God's creation that really doesn't fit into Marsh's way of thinking and isn't really studyable by this hybridization idea. It doesn't work on fossils. This is my big hang-up on this, is the fossil problem. Because there are so many super cool creatures known from the fossil record, and we really can't say much about them if all we can say is things that hybridize belong to the same created kind. Things like Neanderthals, Australopithecus, Archaeopteryx, four-legged whales, feathered dinosaurs, and so on. All very neat things, very much things that I would like to think about and understand better, and I can't do that if I'm only dealing with hybridization. Hybridization can be difficult to justify on endangered species. I'd sure love to know if the giant panda crosses with a grizzly bear or any other bear in the bear family, to know if the giant panda is really a bear or not. I mean, there's some lingering question about that. Obviously, with giant pandas in decline and lots of money being funneled to giant panda conservation. There's no way we're ever going to find that out. So that's unfortunate. I mean, it's good for the pandas, obviously, but it's a bummer for the creationists. Another problem, of course, is the converse is not true. So if you cross your species and they produce offspring, they're members of the same created kind. But if you cross two species and you can't get any offspring, does that mean that they're not members of the same created kind? Well, Marsh was very specific. That does not mean that. It could just be variations and changes and mutations and whatnot that have accumulated since creation that prevents offspring from forming. And so, crossing is evidence of being in the same created kind. Not crossing is not evidence of anything, which means you got to keep working at it, trying other things. And of course, after its kind is not really a reproductive command. So Marsh's biblical mandate, I think, is somewhat iffy. So as I mentioned, in response to these ideas, creationists have tried to develop alternative ways of dealing with things. And one of those ways is this notion of baraminology. And I'm especially interested in questions of statistics. As I mentioned, baraman comes from the Hebrew bara for create and mean for kind. And what we try to do in modern baraminology is to get away from focusing on ancestry. A lot of creationists have become really stuck on trees and whether they belong to the same created kind because they descended from a common ancestor that God created. Okay, fine, but I can't test for that, right? I don't know how to test for whether something shares a common ancestor. So what I would like to be able to do is to just evaluate modern organisms, possibly, hopefully, with just evaluating their similarity and trying to determine whether they form discrete groups. Said this already, I really wanted something to apply to fossils especially, and I want to be able to study discontinuity, which is one of those factors that Marsh talks about in his books, but he never really emphasized in a sort of practical way. His hybridization criterion, as I said, if you make a hybrid, you're in the same created kind. If you don't make a hybrid, who knows? So, let's look at discontinuity here. Marsh says, a point which we are very sure of is that equal with the fact of diversity is that of discontinuity. Organisms cannot be found grading gradually in one into the other. We recognize men, apes, dogs, horses, oak trees, wheat, and roses. So for Marsh here, this is from his Evolution, Creation, and Science book. For Marsh, this idea of discontinuity is really important. And it's really easy to illustrate. You got the horse created kind, right? So you got your horses and your zebras and your donkeys. And you can think of those in your head and you can see they all look pretty horsey, right? Not hard to imagine they would be very similar. Now, what do you suppose is the next most similar thing to a horse? Well, it's either rhinos or tapirs. Those weird snouty guys, that black and white colored things. Very strange looking. Nothing like horses. I mean, they don't look anything like horses. You would never mistake a tapir or a rhino for a horse. So for Marsh, that would be a discontinuity. So the continuity is where they all hybridize and produce offspring, right? So they're all similar. Discontinuity is where they're really different from the next most similar thing. I'm going to define continuity and discontinuity simply as significant holistic similarity or difference, where similarity would be continuity, difference would be discontinuity. I'm going to distinguish that from a simple judgment of similarity or difference because this is something a little more special. We'll look at that here in a second. Now, we can always argue about what this is, and we can definitely argue about what this is. I'm not sure that these terms help us move forward. Right now, there's a new paper today in Answers Research Journal, which is trying to do baraminology on 2 vertebrae, 2 pieces of a backbone. Do you think that's holistic? The answer is no, it's not holistic. Not even close to holistic. So that seems really dubious to me, and probably not something that should ever even been published. On the other hand, we have other studies that I have done have looked at basically craniodental characters, characters that are found in the head and the skull. Is that any better? Is that holistic? No, not really. Is it better? I think there's something to faces that are recognizable that I think makes it slightly better than just a piece of a backbone. Perhaps it's a little more holistic. But I'm still, I'd prefer to use skull data. I'd prefer not to just use backbone data. But you can see how, because we don't really have a hard and fast definition of what is holistic, well, there's always going to be those people who disagree on that. Hopefully we can sort of sort through this eventually. All right, so hybridization. Going back to Marsh's idea, I think we can rehabilitate hybridization because hybridization is both significant and holistic. It is holistic in the sense of you've just taken 2 creatures, you've combined their genomes and their chromosomes into a single cell, and that cell has been able to divide and divide and divide, go through regular development, and produce an adult organism. So you've got similarity at the level of genes, you've got similarity at the level of chromosomes, at the level of biochemistry and proteins, the level of cells, anatomy, morphology. You've got pretty much the whole ball of wax covered in hybridization. So that seems quite holistic. And significance, yes, it's definitely significant because you get an offspring, you get an organism. So I don't really need to trot out my statistics book. I can tell that's pretty significant. So I would say hybridization fits into this scheme as well. Now, statistical baraminology is a little different. This is what we turn to when there's not really hybridization information available. And it's a lot of fun, I think. It's really interesting. And the idea here is to identify significant similarity, hopefully that is indicative of continuity, significant differences, hopefully indicative of discontinuity, and then assess those patterns to detect what we call a holobarometer. And what do I mean by the holobarometer? Well, let's have an imaginary look at this. So think about if you could take an organism and measure every possible characteristic that that organism has. Height, weight, width, whatever. And you could plot that out on a graph that contains every possible dimension that you need. Thousands and thousands of dimensions. You would end up where every organism then ends up as a dot in that graph somewhere. Now, in deference to biologists who may be watching and who may be in the audience, yes, I do understand that organisms are not just numbers and organisms are more than math. That's true. This is a tool to study things, so let's not try to infer that I'm saying that this is all just math, because it's not, obviously. But anyway, you get organisms here as dots in space, and each one is defined by the particular characteristics that it possesses. So a monobarometer then would be understood as species that share continuity. If each one of these dots is a species, then dots that are close together, significantly similar, are a monobarometer. They are a monobarometer. An Brahman then would be species that are discontinuous with all other species, where you could look out here around these two clusters and you find nothing. That would imply that there is a significant difference between this group and everything else. Usually we just assess that by looking qualitatively for the most similar things that are out there, right? We don't actually test zebras versus zebra mussels, for example. We just test zebras versus the next closest thing that there is. All right, so that's an Brahman. Then a holobrahman is both. It is a continuous set of species, so all the species share significant similarity, and it's discontinuous with other species, so it's significantly different from the next nearest species. And what I'm really trying to get at here is sort of that sort of undefinable pattern of life. Are species all sort of gradually grading into one another on some grand evolutionary tree, or do they form discrete groups? And if there is a systematic presence of these discrete groups, well, that would suggest that maybe a model like young-age creationism, which might predict that, would be a little bit better than an evolutionary model which would predict connectivity between everything. And we also speak of successive approximation. Every time we publish one of these studies, it is not the final word. And in fact, now I have published at least 3 different studies of the created kinds, no, 4 different studies of the created kinds of humans. And I have one more in the works right now, hopefully published before the end of the year. So each one is an approximation, and I keep working at it and refining it and making a new approximation, a successive approximation, hopefully getting a better picture of what is in the created kinds. So let me give you my classic example from bunnies. I have a very popular YouTube video about bunnies and their created kinds. You can watch that later. All right, so bunnies, family Leporidae. There are 54 species of rabbits and hares. They are quite diverse, and they are found all over the world. And diversity is expressed in things like the size of the ears. Rabbits living in the cold have small ears to conserve body heat. Rabbits living in hot climates have really big ears to help radiate body heat, that sort of thing. There are also creatures called pikas. Pikas are very similar to rabbits, but they are not rabbits. They don't have those really long ears, right? They basically look like rabbits with tiny little ears. And they don't hop either. All right, so pikas. Now, evolutionary biologists can study the rabbits and the pikas and produce an evolutionary tree that describes their relationships. They find that rabbits and pikas form a clade, a single clade, which they would understand to be a branch of the evolutionary tree. And then there are these outgroups, which are fossil forms. Paleolagous is pretty interesting. Now I can take the data from this tree right here, and I can reanalyze it using a cluster diagram. And this is what I find. Now what I'm looking at here, this is really kind of important. If you don't get anything else, this is what you need to pay attention to. I can't tell you when I'm looking at this tree whether however many created kinds there are in this diagram. I could arbitrarily set it right here and say only these 2 are members of the bunny kind, and these are not. Or I could set it over here. I could set it over here, here. I could say the whole thing is a created kind. I need some way to figure out whether they are a created kind. So what we do is we take the number of characteristics that they have in common. Actually, that's the inverse of that. We take the number of characteristics that they differ by, divide that by the total number of characteristics that we compare, and then create a clustering diagram. This is statistical clustering analysis. This particular analysis is multidimensional scaling. And what we find when we do that, there is a nice tight cluster over here of bunnies, and a nice tight cluster of picas. And there is a substantial difference between each group and each other and the other fossil forms from this research. Okay, so that's interesting. We've got clusters. It's not all one cluster, it's multiple clusters. And this diagram is simply summarizing the similarity. And we use the correlation method to do that. You take these names right here and you imagine that they are along this axis as well, so that, for example, this thing is representing the correlation between Oryctolagus cuniculus and Silvolagus nuttuli. And the squares represent significant similarity, and the open circles represent significant difference. And you can see all the bunnies, all the leporids are significantly similar to every other leporid. And they are significantly different from this group over here, Rhombomylus and Gomphos, which are fossil forms. The Okatonids, the picas, are similar to one another, but they are not significantly different from anything, which is interesting. So you're kind of left with thinking, well, I guess Okatonids are a monobrahmin, but you can't really say for sure they're a holobrahmin. You might guess that they are based on this and say, well, you know, they're way far away. They kind of look like a holobrahmin, but that's a tentative position. This one looks a little bit more like a holobrahmin, although notice there's no obvious negative similarity, dissimilarity here between the picas and the bunnies. So we can't rule out that picas are actually part of the bunnies. But we can say it looks like, based on this at the very least, that the bunnies are a created kind, with the provision that we might include some other things in the future as we learn more about them. But the key here that I think is really important is that there's no set of squares that connect everything together. It's not like everything is significantly similar to everything else and it's all just one big blob. There are discrete groups. Now, what does this mean for ancestry? What does this mean for Grandpa and Grandma Bunny, who got off the ark and gave us all of our modern bunnies? Well, in our work, we would infer that from data that we would consider after we've done the statistical analysis. Hopefully we do the statistical analysis, and it's hard to say, but free of bias. Obviously, I'm heavily biased in many ways, but hopefully I'm trying to let the statistics tell me what the created kind is rather than insisting that I know the created kind and I'm going to prove it. So I try to go into this a little bit agnostic, not pretending like I'm not sure whether there's going to be a clear created kind. But once I have what I think is a created kind, I can make some inferences about what the ancestry might be like. So let's take a moment to think about that. One example here that we might think about is the difference between land animals and other sorts of creatures. So land animals were preserved aboard Noah's Ark, right? Global flood wipes out everything, and what's left is, for the land animals, is on the ark, and there are two of every kind. The ark, the narrative of the flood, is the second major passage in Scripture where you encounter every kind, right? Two of every kind you bring onto the ark. So whatever it was God made in the beginning, bring two of each of those onto the ark. All right, so we're going to assume then that there are two land animals, two of each holobrahmin of land animals. Obviously, there could be more, and obviously what we have found in our biological study may have very little to do with whatever the mean is in the Scripture. We may be way off on that because it's not obvious that they connect directly together, but it's an assumption that gets us going and gets us thinking about diversity and created kinds. So we'll go with that. Land creatures probably had two of each on the ark. So when we're thinking about dispersal, when we're thinking about the diversity of these things and their ancestry, then a land-created kind traces back to 2 on the ark. Horses go back to 2 horses that were on the ark. Bunnies go back to 2 bunnies on the ark, and so forth. Now, if they didn't survive the flood on the ark, if they survived the flood in some other way, then it's entirely possible that you could be preserving diversity of the kind from before the flood. So marine creatures might, maybe, have more than 2 members of each created kind survive the flood, which would then give them a head start on generating more diversity, especially if the forms that survived were relatively different. And that's going to be true for plants as well. We'll come back to that here in a second. The plant thing is really cool. So let's look at an example of ancestry that's always very popular and well received. Horses. Good old horses. Back in the 1870s, T.H. Huxley visited New York City and went through the horse collections at the American Museum. These were brand new, that had just been collected out west, and he looked at these remains and he was very excited because he felt like what he had discovered was evidence of the evolution of the horse. He drew this diagram, which was first published in 1876, showing you from the Eocene all the way up to recent, the gradual transitions that he's found in these various horses from North America. This is still around. Here's the Wikipedia version of the exact same diagram from 2007. The earliest criticism of this horse series that I can find in our library at Core Academy dates back to 1880. So it is pretty much contemporary with Huxley. Huxley was still around when creationists began criticizing the horse series. So no doubt they will love what I have to say. All right, so here is a modern phylogeny of horses showing the relationships of the horses, a large set of horses here. This is putative, I should say. This is actually probably a combination of multiple trees. It's not actually a single set of characters that produce this set, so that's kind of a bummer. But there is a set of characters, mostly from, again, the skulls. And when you analyze those in a clustering fashion, you find this. I got 2 different clustering methods here, multidimensional scaling, and a technique called analysis of pattern. And you have what basically looks like a single line here, in both cases, with a branch that sticks off over there. What's interesting about this is that the order in this line matches up really well with the order in the fossil record. And not only that, but it matches up really well with the evolutionary tree as well. So if you look at the evolutionary tree here, you start off with things like Heractherium and Oropus and Epihippus, all of which are here. Then you have Myohippus, which is here, after which there is a grand branching, where you have Megahippus, Hypohippus, Anchitherium, Colobotippus, all of which show up right over here on this branch as well. And then you have a big cluster of very recent horses which show up right there. So that was interesting. I was surprised. I have done literally hundreds of these sorts of clustering analysis. This is the only time that I've ever found one that just spit out the evolutionary tree right back at me. That doesn't usually happen, and that impressed me greatly. I can also look at the correlations and similarities. There is similarity across the entire thing. Now, some people want to argue that's a discontinuity or that's a discontinuity. That's fine. It doesn't really matter. My analysis doesn't support that, so I'm going to go with my statistics, which suggests that those 175 different fossil horses from after the flood are descended from a common ancestral pair. So the horse series, which has long been the whipping boy of creationism, that may have been premature whipping. It may turn out that this is actually pretty good evidence for the diversification of horses after the flood. And what's really exciting about that is that there's a lot of mammal series that do the same sorts of things in the fossil record. It's not just the horses. The horses just get celebrated. Well, people like horses, and Huxley started it, so people talk about horse evolution. But you could talk about rhinos and elephants and camels and all the other sorts of groups of mammals out there. And if they're all just representing the diversity of creatures after the flood within a created kind, that would be really cool. So that was a surprise. I did the horses. I come up with this thing that looks like, all right, well, maybe horses all belong to a single created kind. But I've done other things with whales that show slightly different pictures. So whales here, modern whales come in two flavors. You have odontocetes, which are the toothed whales, and mysticetes, which are the baleen whales. The baleen whales being those guys with the really big giant sheets of weird stuff in their mouth that they use to filter microscopic little tiny critters out of the water to eat. Stephen Jay Gould, in one of his essays, talked about the whale series and how at one point he was embarrassed because he couldn't explain the evolution of the whale. But during the past 15 years, he says, new discoveries in Africa and Pakistan greatly added to our paleontological knowledge of the earliest history of whales. The embarrassment of past absence has been replaced by of transitional fossils and evolutionists could hope to find. So, keep that in mind. This is the sweetest series. And frankly, I don't think he's terribly wrong with his excitement. So here's one of those early whales. This is Dorodon. And Dorodon, really beautiful whale. How do we know it's a whale? Largely to do with the structure of the inner ear and other characteristics of the skeleton that it shares in common with modern whales and nothing else. But what's weird about Dorodon, you can see it right there, Dorodon has tiny little hind legs, which is kind of cool. And there are others. This is Rhodocetus. This is the pelvis of Rhodocetus. And you can see in the case of Dorodon, it attaches to a pelvis that is completely detached from the backbone. But with Rhodocetus, the pelvis is actually quite complete and attached to the backbone. And there's a nice leg bone coming off of it. And when we look at modern whale skeletons, we also find, surprisingly, these little tiny bones right back here where the hips ought to be. Sure look like they might be something like a hip bone trying to grow. Just a tiny little snub of one. So I don't think it's terribly stupid to think that whales, that what we think of as whales, might have diversified from something semi-aquatic like a hippopotamus. That sounds crazy, but I've seen weirder things in baraminology, so it's possible. So let's test it and find out, right? So we got baraminology, let's see what we get. So here is a phylogeny of whales. All the living whales here, or a lot of the living whales here, most of them are toothed whales. The baleen whales in blue. This green guy is the Archaeoceti, which are those weird four-legged whale creatures. And we have a bunch of things that are not whales, the land animals. And the statistics show me something very different from what I got with the horses. There are very clear, discrete groups of whales. They do not form a single cluster. There are multiple, very clear clusters of separate creatures. And the Archaeocetes tend to be much closer to the land animals than they are to any of the living whales. Which doesn't surprise me, because when I look at an Archaeocete, it doesn't really look like a modern whale. It looks like something weird. Another analysis, looking more carefully at these Archaeocetes, a lot more diverse sampling here, along with something called mesonychids. Mesonychids are really odd creatures. Imagine a deer with the head of a wolf, so a hoofed creature that is carnivorous. That is a mesonychid. And here are some of those whales, and you can see Pachycetus here looks very much like a four-legged version of Dorodon. Those skulls, you can see how similar those skulls are. They're rather striking. And then you have Balænoptera over here, one of the modern baleen whales. When we reanalyze that using our clustering method, we find, well, not clear what we find. Here are all the land animals, here are the mesonychids, here are the archaeocetes widely dispersed, and over here are the modern whales. Not much clustering going on here. This is just a big blob, but I do notice that you don't have anything where land animals are intermediate between, land animals have an intermediate phase between them and whales, unless you go in this weird U-shaped pattern, which is weird. Another character set here from 2004 produces, again, the mesonychids are very close to the archaeocetes, which are very far away from the modern whales. My suspicion is mesonychids might be related to the archaeocetes. They might form a single created kind, and that some of the archaeocetes become, as they diversify and produce new species, they become a little more adapted to the life of the ocean. But I don't think they become whales. Now, again, remember, each time I do this, we're doing an approximation. We might change that in the future. We might throw in some more fossil whales, or we might take some out. But as of this study, as of this point, I can't really say that whales belong in the same created kind as archaeocetes. And they certainly, baleen whales certainly don't belong in the same created kind as the modern toothed whales. Yeah, that's what I just said. Sweet series, maybe. I see the sweetest series in the horses. That certainly comes back from my statistical analysis, but I don't see that in the whales. So it's different. So, some lingering questions here. Does this mean anything? I think it's always important for scientists to sit back and say, what have I done? What significance does this have? I have taken statistical clustering methods, I've applied them to character sets that are used to create phylogenies, and I have found over and over again the presence of clusters and not just clouds of text that all blur together. All right? Does that mean that that correlates to the same sort of thing as what we find when we cross creatures together, right? When we hybridize them? Does either of those things have anything to do with what God's talking about when he says, I've created these creatures after their kind? I'm not sure how to answer those questions, honestly. I'd like to know more, but there's the phraseology in Genesis is too rare in the scripture after its kind. It's hard to know what it's talking about, and it doesn't really spell it out. I mean, I can sort of get the idea that it's talking about diversity of animals. It's distinct from the image of God, which is how he creates us. But what is it? Second big question. We need independent ways of verifying these results. So I've done one way with one metric. I've got a book full of clustering methods. There are lots of other ways of doing this, and we need to independently verify what we're doing, because good scientists always independently verify what they do. So this is a need that has to happen. Can we integrate genetics with baraminology? So that's 175 horse species is a lot of horses, right? And I'm saying that's after the flood. That's a tough pill to swallow, honestly. How does that work with genetics? So that's a talk I'll be doing tomorrow, talking about the wonders of biological change and what we've learned from comparative genomics, looking at species that we can be really pretty sure belong to the same created kind, and what do we find in their genomes that help us to understand how they might have become different. And then the larger question, why are Brahmins similar? So Darwin understood things to be all related to a common ancestor, or a handful of common ancestors, because he could see similarities across many different groups. So for example, a dog has a backbone, just like you have a backbone, right? But you don't belong to the same created kind as a dog. So why do you both have backbones? And you might say, well, there's a common designer, right? Well, yeah, that's true. There is a common designer. But why did he give the dog a backbone but not a jellyfish? So lots of interesting puzzles going on here. Why are whales mammals and there are fish? Why did the ocean need mammal-like, fishy-looking mammals? I don't know. And we kind of laugh at that, and it's a weird question, and maybe it's impertinent, and maybe it's impious. I shouldn't be asking those such questions, but it strikes me as really striking at what Darwin is saying with his argument for universal common ancestry. You can't stop looking at similarities. Just because they might be significantly different, there's still things like mammals, and there's still things like carnivorous mammals, like the bears and the dogs and the cats. They exist. These groups are they're recognizable. So what do they mean? So more information, check out all of our internet pages. Follow my blog. You can subscribe to it. You can like us on Facebook, stalk us on Twitter, whatever your favorite little social whatever it is. And that's all I have for today. So tomorrow we're going to talk about what happens when you apply this stuff to human beings. That'll be right after the afternoon plenary.